Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have x to the power of 6 minus x cubed equals to 2, and we solve this problem for the real values of x. So the very first step we are going to do is here first we rewrite this equation as, here we have x to the power of 6 and we write it as x cubed and its whole squared minus, here we have x cubed equals to 2. So in the next step, here you see that we have x cubed be the common term, so that we will take this term equals to y. So here we take our y equals to x cubed, and when we substitute the value of this y to the above equation, so our above equation will becomes in quadratic form. So it is y square minus y equals to 2. But here this equation is not in standard quadratic form, so we move this 2 in the left hand side and we convert this into the standard quadratic form, and it is y squared minus y minus 2 equals to 0. So this is our quadratic equation, and now here we have different methods to solve this quadratic equation. So here we break its middle term and we easily make the factors of this equation. So here we write this y squared and we break its middle term, so our middle term is minus y and we write it as minus 2y and plus y. So because minus y and we write minus 2 plus 1 becomes minus y, and this is minus 2 equals to 0. So here we easily make the factors of this equation, and now we take common y from first two terms and we take common plus 1 from the remaining two terms. So here we take common y and we obtain y minus 2 times y into y minus 2, plus here we take common plus 1 and we get y minus 2 equals to 0. So in the next step we have y minus 2 be the common factor, so we take it common y minus 2 and we obtain, here we take common y minus 2 and we get y, plus here we take common y minus 2 and we get 1 equals to 0. So here we have two cases. The first case is we write y minus 2 equals to 0, and the second case is we write y plus 1 equals to 0. So in the first case we get the value of y equals to 2, and in the second case we get the value of y equals to minus 1. So here we back substitute the value of y, because in the start of the problem we take our y equals to x cube, so we back substitute this value here. So now we back substitute the value of y and we get here x cubed equals to 2, and here we get x cubed equals to minus 1. So in the next step you see here here we easily get the value of x if we take the cube root on both of the sides. So that here we take cube roots on both of the sides and we get the first real root here, so it will becomes, so you see here this 3 and 3 are cancelled by each other, and here we get the value of x equals to 2 to the power of 1 over 3. So this is our first real root of this question. And now in order to find the other real roots, we need to solve this cubic equation. So here first we copy down this equation here and we get x cubed equals to minus 1. So now we solve this cubic equation here. So here we move this minus 1 to the left hand side and it will becomes x cubed plus 1 equals to 0. So if we make the cube of this 1, then you see here it will becomes x cube plus 1 cube. And now we use here the nice cubic formula, and you know that if we have a cubed plus b cubed, it is equals to a plus b times of a square minus ab plus b square. So here we use this nice cubic formula. So the above equation after using this formula will be written as x plus 1 times of x square minus x plus 1 square equals to 0. So here we have again two cases. The first case is we write x plus 1 equals to 0, and the second case is we write x square minus x plus 1 equals to 0. Here you see that 1 square becomes 1. So here we get the second real root is x equals to minus 1. So this is our second real root of this question. And now in order to find the other roots, we need to solve this quadratic equation. So here first we check that is this quadratic equation has real roots or not by using the discriminant formula. So first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 1, and c equals to 1. And you know that the discriminant formula is delta equals to b squared minus 4 times of ac. So this is the our delta, and now we substitute the values of a, b and c here, and we check the behavior of this delta. So we substitute the value of b, it is minus 1 square minus 4 times of a is 1 and c is 1. So we get here minus 1 square becomes plus 1 and minus 4 times of 1 becomes 4. So you get the value of delta equals to minus 3. And you see here our delta is less than 0. It means that this quadratic equation has not real root. So that we rejected this case because we need only real roots in this question. So that we have only two real roots in this problem, and these real roots are x equals to minus 1 and x equals to 2 to the power of 1 over 3. So we have these two real roots. And now we check these two roots, is these roots are satisfied our given question statement or not. So that here we copy down our question statement. It is x to the power of 6 minus x cubed equals to 3. So now we check, first we check this x equals to minus 1 here, and so that we substitute x equals to minus 1, and we get minus 1 to the power of 6 minus 1 to the power of 3 equals to 2. Sorry, this is our 2. So you see that if we have the negative sign have exponent even number, so it will becomes positive 1, and if we have the negative sign with odd exponent, it will becomes minus 1, so equals to 2. So this minus times of minus becomes 1 plus 1 equals to 2, and we get 2 equals to 2. So this shows that x equals to minus 1 satisfied the given question statement. So now we check the second root, which is x equals to 2 to the power of 1 over 3, and we substitute it here, and you get 2 to the power of 1 over 3 and its whole power 6 minus 2 to the power of 1 over 3 and its whole cubed equals to 2. So here you see that this 3 2s are 6, and we get 2 to the power of 2 minus these 3 are cancelled out by this 3, and we get only 2 equals to 2. So this 2 square become 4 minus 2 is 2 equals to 2. This shows that x equals to 3 to the power of 1 over 1 over 3 be the solution, second solution of the given question, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.